So the SeaBat T-Series is a generation of the next generation after we had the 7125 series or the 7K series for many years, and some years ago we introduced the T-Series. We introduced first the portable version, the T20 and T50P. They are in concept portable, and we've seen them installed on various even very small vessels. This is Zainul from Malaysia doing a demonstration of a T20P on a jet ski for the Malaysian Navy. Then we have a rack-mounted solution that goes on all normal, smaller and bigger survey vessels, research vessels also. It comes in both a single head version and an integrated dual head. When I say integrated dual head, I mean one topside, two sonar heads. The last one we have is a Subsea sonar processor that fits on AUVs, ROVs, deep tows, has integrated onboard storage, also comes in a single head and a dual head version. So those are the three the different topsides, but they basically contain the same type hardware internally, and therefore also produces the same sort of data quality. We know for several years now we've had really good feedback on the T-Series, and I know some of these small catchphrases are a little bit marketing wise, but they're not wrong. We do see the best and the cleanest data we've ever seen from any of the SeaBat sonars, and the feedback is that our customers, they spend less time data cleaning and data processing, which means they can turn around their data quicker. So when I say it's catchphrases, we didn't come up with them ourselves. Before we launched the T50, we had a couple of beta customers helping us out, giving us valuable feedback on data quality, on functionality. Is there something that doesn't work? What works really well? And that was Port Authority of New South Wales, so in Sydney ports. They took off their existing and fully functional 7125 SeaBat 7125 and installed a not released T50. So they took that risk, and they were super excited with the results. And they gave us some of those catchphrases. The same with Port of Hamburg or Hamburg Port Authority. They gave us similar feedback, both in terms of functionality, but especially on data quality. So that with that, we believe that the T-Series, and especially the T50, but both the T20 and the T50, they set the benchmark in the shallow water market. So we are quite proud of that. But there's a reason they work so well, and they provide us with such good data. And those two are the features. Well, partially those two features, tracker and normalized backscatter, they are a subsystem of should I say this? They are integral. Anyway, they're important. But let's start with Tracker Autopilot. Tracker Autopilot is our way of saying automated operation. So hands-free operation, where you still can trust that you get good data, and you can, because it's automated, you don't need a 10-year trained hydrographic surveyor to operate your sonar, or just less. You can basically set almost anyone in front of the sonar, and then with Tracker you will get good data. Tracker is not a new thing. On Autopilot as such is not a new thing. We had Autopilot even with the 7125s and the 8125 hybrids, but they were sort of it was more of a lookup table. It wasn't so much Autopilot, it was more pilot than auto. Just a sip of water. More pilot than automatic. So it would look at what's my depth, and then it would have a lookup table saying at 30 meters I will use these settings, at 35 meters I will use these settings. So that's what I mean about when you then move from a certain one area to another area, you would have to load a different lookup table. So you'd have to do that manually. The tracker Autopilot is completely different. it doesn't only look at the range, it also looks at data quality, what comes back to the receiver. So how is the reflectivity of my signal return? What's the uncertainty of my signal return? And then we've set up algorithms to control everything. Range, source level, pulse length, absorption, spreading, coverage, everything. Coverage, you can set tracker to even control your swath coverage. So if you have good data, you can open up your swath, or tracker can open up your swath completely automatically. But it means, and those settings here, source level, pulse length, gain should be in there as well. They are the settings that an operator would typically fiddle around with for an entire survey. You don't have to do that with tracker. You click tracker and you get good data. That's the whole concept. Now tracker is also, because tracker monitors the signal strength return, tracker will continuously make sure that we don't saturate the incoming signal, which means that we will also get good backscatter. But we will be changing settings, or tracker will be changing settings continuously based on the seabed return. If you're on hard seabed, it will give you lower the gain. Soft seabed, it will up the gain. So it will change everything, or many of the settings, in real time. Our concept when we introduced tracker was that tracker should be as good or better and faster compared with a trained hydrographic surveyor. And we do believe we've made that cut. Tracker not only provides you with the I'm not going to say perfect data, but close to. Tracker doesn't only give you really good data, it also optimizes your ping rate, because tracker will continuously try to operate the sonar at the optimal ping rate. And you can see over to the right, where we have a backscatter waterfall display, you can see how range has been changed with a 1 meter changes to range, which means that tracker is continuously updating the range setting to be optimal. That's better. That's even better than you can do manually, because you only have, say, a 25 meter range setting, 35, 45, 65, 100, where tracker will do that in 1 meter steps. So using tracker will optimize your ping rate and effectively give you a higher sound density. Tracker is a one button thing. So you literally power up your sonar, you click tracker, and suddenly you see the seabed. But the tracker works super well in combination with what we call adaptive gates. Adaptive gates, they are those two yellow lines you can see going across the current ping. And unlike traditional gates, it's not a fixed range, or a fixed range with a slope, or a fixed depth. Fixed depth with a slope, or it's autonomous and it's adaptive. So adaptive gates, they will continuously follow the seabed and follow the features of the seabed. And if they detect low quality data, they will turn themselves off. A good example, you're surveying along and you pass through some wash from a ship that passed in front of you. So annoying, isn't it? And obviously our detections, they will detect on all those bubbles, but those bubbles are by definition low quality data, because they are not in choline and they have low reflectivity compared to traditional seabed. So the adaptive gates, they will turn themselves off and stay off until we see the seabed again, and they will then log on to the seabed again. So tracker, adaptive gates is a one button solution, and I'll show you a very short video of a short data set where you can see, first you'll just see noise, then you can see the operator, he moves his mouse up to the top, in the top middle, he clicks tracker. Initially the settings are just some weird settings, but tracker will then almost instantaneously detect where the seabed is, and start detecting on the seabed, so bottom detect on the seabed, and then enable the adaptive gates. And there you go. And you will actually see that. Well, let me just run the video. I hope it runs reasonably smooth. So maybe Helle, can you confirm that the video is running smooth?
Yes.
Okay, very good. All right, so we start seeing noise, and the operator, he moves his mouse up to the top, he clicks tracker, and you can see how now immediately the gates, the adaptive gates, they turn themselves back on after being off, because when we don't have any sound in the water, we have low quality data. So they turn themselves on, and you can see how the sonar to start with gains up a little bit too much, and then after a few seconds it has gained down to find the optimal settings. So to start with, it's probably be saturated, but after a few seconds, boom, you're ready to go. So that's tracker, and tracker will then you just leave. You can. It's strange how things they have changed. Go back 5-6 years, and when I did demonstrations, it was fiddling around with sonar settings and explaining how great the sonar is. Today, it's about clicking tracker, and then you can talk about everything about where you use the sonar, cleanliness of data, how much time you can save. So yeah, tracker is a very, very powerful feature, but it will change your sonar settings in real time. And that's not always what you want, especially not if you're looking at acquiring backscatter data at the same time. And for that, we've introduced normalized backscatter. So I'm not going to go into a PhD or anything about what bathymetry and what especially backscatter is, because that's way above my level of knowledge. But what we know and what we can see is that backscatter, from the same data, you collect both bathymetry and you collect backscatter, and you can see that there is a difference. So where you have features in the bathymetry, you may or may not have features in the backscatter, as we can see here. So we are getting more information out of the backscatter and information about the seabed from backscatter. But backscatter, so again, don't worry, it's not going to be super advanced here. So we transmit. If this had been a pool table, all the sound would just reflect away. Incident angle equals exit angle, or incoming angle equals outgoing angle. But because the seabed is not a pool table, some of that sound will return to us. It will scatter back. So that's where the term backscatter comes from. So some of the sound will scatter back to us, and depending on what the seabed looks like, depending on how highly reflective it is, how hard it is, the amount of sound that scatters back to us is different. So we will sample a number of samples. We will log, record a number of samples around that bottom detection, and that is our backscatter. That is a snippet. The problem with backscatter is that it has traditionally, not traditionally, but we've just seen a lot of really bad or low quality, lower than what we would like to see quality backscatter. And the demand has increased. So we have seen increasing demand for good backscatter. And I'm sure that some of you will recognize when I say that it's just been standard that you find out what settings you want to run if you're doing a backscatter survey or combined bathymetry and backscatter survey. It's been almost like industry standard that find some settings that works for the entire area and don't touch the settings. We will then get good backscatter, and you will. But the problem is that you often can't use the same settings, not if you want to make it ideal for the entire survey area, and it's certainly not if you're using tracker, because tracker will change settings depending on what the seabed return is. So in these darker areas, you would probably see tracker increase the gain or increase the source level, change something. And if the software doesn't know the sonar characteristics well enough, you would get artifacts. We're trying to move away from that with the T-Series, and we believe we've made a very good step along those ways. And we have customers using Normalized Backscatter with great success. So how come we can suddenly allow changes to sonar settings that we couldn't do before? And that has to do with hardware. It has to do with better receiver electronics. It has to do with better knowledge about the acoustic properties and the acoustic characteristics of our transducers and topsides also. And we simply know our transducers better today and with this generation than we did with the generation before that, 7K generation, that was developed in the early 2000s, right? Introduced in 2004, 2005. It's 15, 16 years ago. So no wonder we know the acoustics and the characteristics of our transducers better. So what do I mean when I say we know them better? If we start with transmit, you have a slider in the UI, in the user interface. That slider will have a dB value, a source level value of, say, 216 dB. That's not the same as saying that we necessarily get 216 dB out at the end of the transducer into the water, but we know what that value is. We know how much source level we produce in the water. So you can say that the slider is more like a nominal value, but we know what that correct value is. And that's why some of you, if you use the T-Series, you have to put in cable length, because we account for the signal loss in the transmit cable. The source level also changes with different frequencies. So 216 dB on the slider at 400 kilohertz is not the same. It's not the same source level at 350 and 320 and 270. So those, but all those numbers, we know them, and therefore we can account for them. On the receiver side, the receiver electronics, especially the receiver electronics, has improved tremendously. Oh, that's Mrs. Bull just walking in the door. The receiver electronics has improved tremendously. And we today have almost perfectly linear receiver responses, which means if the seabed responds at 5 dB difference on the older, the previous generations, that may not end up in a 5 dB difference, but with the new receivers, the T-Series receivers, they most definitely do. So receiver electronics and knowledge about how much source level we put into the water. We also we've also done some pretty complex footprint calculations. So we account for the footprint, because that's not straightforward. I thought it was straightforward. I was told that's Uni Bull. This is not straightforward. This is pretty complex. So so we account for different types of footprint, including a cross-track slope, because a slope will also change the footprint area on this on any pin. So what does that give us? It gives us a new output that gives us with a true backscattering strength estimation. So instead of just some arbitrary value, that is perfectly fine if you don't change any settings, and you can probably make something pretty nicely looking out of that mosaics. But with Normalized Backscatter and with the components, both the transducer components we now have, we can change settings. We can allow the sonar to change settings automatically, and thereby providing our customers with both good bathymetry and good backscatter at the same time. And as you can see, we see almost artifact-free, I mean, virtually artifact-free data it's not like it's not 100%, but it is pretty darn close. And this is the only compensation that the software needs to do is to compensate for the angle. Normalized Backscatter is supported by all the major software houses that we know. FMGT is really nice. They do some very nice visualizations. So that is what Normalized Backscatter is. It's a virtually artifact-free backscatter data set. And you can, I mean, in this video that is running right now, you can just see low resolution at nadir striping with a little bit lower resolution. But it looks pretty good. And those values that you read out from that mosaic, they are true dB value. And they were acquired with changes to sonar settings in real time and compensated for the same in real time. So with that, a quick summary. A T-Series system with impressively, and I mean, I know I work for the company. I'm not that naive, but it is very impressive how clean the data you get out of T-Series is. That's the feedback we get over and over again. And customers are excited about the shorter turnaround time they have when using a T-Series. Tracker, one button solution, click tracker, detect the seabed, adaptive gates will start up automatically, and you have reliable and repeatable data. Because we have tracker, we need normalized backscatter. Because we have tracker, we can allow ourselves to change setting. Oh, sorry. Because we have normalized backscatter, we can allow ourselves to change our real-time settings. That is exciting because that means that we can get good bathymetry and good backscatter from that same survey or from that same data acquisition. So with that, I think that's about it, and I will. Well, Helle, you can see if we have any questions coming in on the chat. So thank you. How many are we? We are some 70, I think.
Yeah.
Well, over to you, Helle.
Thank you, Uni. That was very interesting, and I hope everybody got a lot out of it. We have a few questions, and I will also start the last poll questions while I read out some of the questions. So, Uni, the first question I have here is, I don't think we will purchase the normalized backscatter option. We don't collect a lot of backscatter anyway. What is the cost of getting the tracker license without normalized backscatter?
Yeah, let me start with normalized backscatter. Normalized backscatter is a licensed add-on purchase. So when you get a T-Series, a T20 or T50, you have to buy that license to get the normalized backscatter output. Tracker is always included. Tracker is a part of the T-Series. So there's no extra cost. If you only want tracker, go with it. You just get your T-Series. We take orders later. No, just kidding. Tracker is always there, and it works on all the T-Series systems. Normalized backscatter is a licensed feature.
Okay, yep. Thank you. There's another question here. I saw a posting about version 2 updates for the T50 recently. Does that include the latest tracker feature?
Yeah, that's true. We is it a couple of months ago we released a new software firmware update for the T-Series, introducing some very exciting features that some of them were not reflected in this presentation actually. And one of them was that we introduced normalized backscatter also for T20. Until now, it's only been available for T50, but we've now introduced it also for the T20. The version 2 update also increases the number of beams from 512 to 1024 beams. And and there's an updated UI that it sounds like it's unnecessary, but it really helps. We have introduced color by depth. So the waterfall display that we've seen several examples of in this presentation. Actually, I can go back and find one of them, if that's right. This waterfall display, that waterfall display. That waterfall display is now has an option of being colored by depth. So you know how red is shallow and blue is deep. And it seems like, is that really necessary? No, it's not necessary, but it just helps you a lot when you are looking at features and you want to have an immediate interpretation of what the seabed looks like. We also introduced some easier raw data logging features. So it's a very exciting update, and it is free. And you can go to our website, teledynemarine.com, go to the support site, and then there should be a mail address to our support. Write to them. I'd like the seaBat 2.0 update. Give them your license ID that you can find in your user interface, and then they will send you the update. It's free of charge. And Tracker is the latest iteration of Tracker. Yes, is included in 2.0. We haven't done any changes to Tracker from 1.6 to 2.0, but it is included.
Great. So Uni, we're coming up on time here. I will just launch the last poll, and
oh, sorry about that.
No, let people answer that. And
no more
thank
questions?
you for your time. There was one more, but we can take that even though we are just over time.
Okay.
Maybe you already explained this. Could you explain again why Tracker controls everything but not frequency?
Oh, I don't actually if I mentioned that. I didn't go into details, but yeah. So Tracker controls pulse length, gain, absorption spreading, all the basic sonar settings, but we do not control. It also controls the swath coverage if you want to, but it does not control frequency. And the reason for that is that the seabed responds differently to different frequencies. So if you run a 400 kilohertz survey and it gets deeper and deeper and deeper, you don't want an automated algorithm to suddenly change that frequency from 400 to 350 or to 300. You want to be in control of that. So Tracker will control everything except for frequency. Sorry for running a little bit late.
Right. Okay. I guess we will stop here.
All
and
right.
Thank you, Uni.
No worries.
Thank you very much, everybody, for listening in. And I hope this was useful. It looks like that for the poll. 80% of you so far has said it's very helpful. So have a nice day, and thank you for joining.
Yeah, have a good one. See ya.